All right, so welcome to section 6.5, finding real roots of polynomial equations. In this video, we're going to talk about, what the importance of factoring was, because factoring is half the battle. It's most of the battle, really, but we talked a long time ago when we did quadratic equations. We had the factor quadratics, and after we factored quadratics, we were able to look at those factors and find the roots of them when we set them equal to 0. So it's the same idea for polynomials. It's just polynomials are just another step up because, there's more than just quadratics when it comes to polynomials. But some of it is quadratics. So roots, just a reminder, roots, zero, solutions, whatever you want to call them, of polynomials are points where the function equals 0, aka the x-intercept. So if you take any polynomial that you want and you graph it, you look at that graph and you notice where that graph crosses the x-axis, and those are your zeros. So I've got a really terrible sketch here, but you can kind of get the idea that the zeros are, of course, where this this function intersects the x-axis, which is in 3 different points there. So just to try out some of that, just to test your ability to basically look at a graph, I've got 2 examples quickly here, just showing you 2 graphs and asking you kind of what the zeros of them are. So for the graph on the left, notice it's got across the x-axis there, which is at -2, crosses it here, which is at 0, and here, which is at 1. So its zeros or solutions are x equal -2, x equals 0, and x equals 1. Now you can write it all out like this if you want to, saying x equals this, x equals that, yada yada. Or, and this is kind of how the EOC folks will probably do it, they'll write x equals, and they'll write the answer as a set. So x equals -2, 0, and 1. And they'll write it in like a little squiggly bracket set. So don't get, confused when you see this notation. It's just a different format, just a different way to write the answer. So it looks kind of odd, and it's not really meaning anything mathematical other than just saying, hey, x is these 3 numbers. So we're not going to just list them all out. We can just put them all in kind of one answer. So let's do the same thing with the other graph. So the other graph, it's got 2 x-intercepts, as you can see. One here at -1 and one here at +2. So its x-intercepts, we can say its solutions are x equals -1 and 2. There you go. I wrote it in the brackets again, just to, get you a little bit more familiar with it. Now, some of these questions I'm going to skip on here, but you're welcome to look at them if you want to, but I'm just going to get to move around, get point across. All right. So as long as you can basically look at a graph and know where it's crossing the x-axis, you know how to do, that much of it. Now we're going to move on to finding solutions of polynomials, not from a graph though, but from the actual polynomial. But we're going to look at ones that are already factored. So we could have examples, where we have x to the third plus 2x squared minus 4x plus 7, right, equals 0. But we're not going to be able to know what the x-intercepts are unless we graph it or factor it. What I'm showing you here is examples where those polynomials are already factored. So someone's already done all the hard work and factored a polynomial for us, and we got these 3 factors, x plus 3, x minus 1, and x plus 7. So once it's already factored, it's pretty easy because each of these is set equal to 0. So you want to know the x value that crosses the x-axis when y is 0. Well, you just take each of these factors and set it equal to 0 to solve. So you take x plus 3, set it equal to 0, and solve it for x to know where it would cross the x-axis at y when y is 0. So it crosses at -3, and you can do that for the other ones as well. For x minus 1 equal to 0, you just add 1 to both sides, and you'd see that x equals a +1. And for the other one, x plus 7 equals 0, again, just subtracting 7 on both sides, you'll see that x equals -7. So there are these 3 x-intercepts. Whatever this graph looks like, I'm not really too sure without actually graphing it, but I do know that it crosses the x-axis at -3, -7, and 1. So if you drew a graph or something or sketched out whatever, This would have an x-axis intercept at 1, at -3, and at -7. So it probably goes something like this, who knows? All right, just one more quick example. Again, this polynomial here has already been factored, so it's in its most factored form. So we're just going to look at these and figure out where x is 0 for each factor. So there's 3 factors. We have 3x, x minus 4, and 2x plus 3. So yes, the 3x counts as a factor. It has an x in it, and it's its own little piece. It's not being added or subtracted to anything, but it is its own little piece. So just like before, you would take each of these 3 groups, set them equal to 0, and solve for x. So let's take the first one, which is 3x, set it equal to 0. And when you solve it, 0 divided by 3 is still 0, so x equals 0 is one of the answers, is one of the, x-intercepts one of the solutions. You can take the x minus 4, do the same thing, set it up equal to 0, and solve this for x. You have x equal to positive 4, so positive 4 is another answer. And the one that's not so obvious, which is why I wanted to throw it in here, was a 2x plus 3. So again, it's not as straightforward as the other ones, but because you are going to get a fraction here, but it works the same way. You take the 2x plus 3, set it equal to 0, and solve. So subtract 3, and then divide by 2, and you would get x equal to -3 over 2, -3 halves. So -3 over 2. So those are the 3 solutions from those 3 factors. Now moving on to polynomials that aren't factored, that are not graphed. Now I'm gonna talk you through kind of what I would do on the calculator. If I get a calculator on my screen at any point, I will sure to make a video of how to do this, but I'll just talk you through the buttons. So if we want the calculator to find the roots of this for us without actually having to factor it, without actually having to graph it, here's what you would do. So you'd take your graphing calculator, and I'll kind of walk you through the steps. If you have one on hand, just kind of do as I say here. It's not going to be very easy because I don't have one to show you, but I'll try to talk you through what you would do. So the first thing you're going to do if you take a graphing calculator is hit the apps button. So apps button is sort of like near the math button, kind of near the alpha button. Sometimes it's a different color. So you want to hit the apps button, and then you want to make sure that in the list of apps that it gives you, one of those apps is this one. So PLY SMLT2. Okay, that app. You're going to choose that app, and it gives you like a welcome screen. You can just hit enter through it. And on the main menu, you're going to choose, I think it's the first option, Polynomial Root Finder. I mean, it says it in the name exactly what it does. It's going to find the roots of our polynomial. So once you've selected that, there's a lot of weird options it gives you. But one of the options, and being at the very top, says order. And it gives you like a list of numbers. I don't know if it starts with 0, if it starts with 1, but it gives you a list of numbers. And basically what this wants is it wants the degree of your polynomial. So if you're going to use this example, the highest degree in this polynomial is 6, right? That's the biggest exponent. It goes up to x to the 6th power. So as far as order goes, you would scroll over and select 6 for this problem as the order. You shouldn't have to change any of the other numbers. Now you want to go to the next button. It says next at the bottom of your calculator, but to hit that button, you can't hit enter. You have to hit the graph button, because next, if you look at the graph button, it's right under next. So it's kind of like F5 button or something. But to hit next, you actually have to hit the graph button. And now once at that screen, you have to type in the coefficients for your polynomial. So it shows up as it'll show up as A6, A5, A4, A3, A2, A1, and A0. So basically, the calculator is wanting you to tell it, because it knows it's a 6-degree polynomial, so therefore it's why it's starting with A6, is what's the coefficient for the x to the 6th term. So for the x to the 6th term, the coefficient is 4, so you would type in 4. You don't have to type in any x's or anything, you just need to type in the number. The calculator knows what you mean when you put 4 in for that a to 6 spot. It means it's 4 to the x to the 6th power. For the a5th, it's wanting the coefficient for the x to the 5th degree, or 5th power, which again is also 4, so you type in 4 there. And then for a to the 4th, it wants to know the coefficient for the x to the 4th term, which in this case is a negative 24, so be careful with your negatives. Now in this problem, there is no x to the 3rd, there is no x to the 2nd, or x term, or constant term, so all of those would be 0. And again, if you want to solve it, it says solve at the bottom. You have to hit graph again to solve it because graph is like that F5 button. So hitting the graph button will solve it for you, and it will give you a list of all the roots. So you've gotten your roots. You'll see it on your calculator, but now let me show you what to do here, how you can just do it by hand, okay? So for this function, or this polynomial, I'm going to try to solve it by factoring, as it says by factoring. Now, noticing the 3 terms here, all 3 terms are divisible by 4x to the 4th. 4, 4, and 24 are all divisible by 4. And each of these has at least an x to the 4th. So that is your GCF 4x to the 4th. So I factor 4x to the 4th out. And when I do that, those will cancel and leave me with an x squared. These will cancel and leave me with an x. And the x to the 4th cancel, and negative 24 over 4 is negative 6. So when I factor out a GCF, I'm left with x squared plus x minus 6. But now this x squared plus x minus 6 is still factorable. I can solve that because of the trinomial using product and sum. So a times c is 1 times negative 6. So 1 times negative 6 is negative 6. So I'm looking for 2 numbers that multiply to make negative 6. And my b value is 1 since it's 1x. So I'm looking for 2 numbers that multiply to make negative 6. And the same 2 numbers that add to equal positive 1. So what 2 numbers multiply to make negative 6, add to make a positive 1? Well, I believe it would be 3 and negative 2. Yes, so 3 and negative 2. Now, thankfully, a is 1 here. And when a is 1, that means these 2 numbers are my factors. So just using the little shortcut, these factors are going to be x plus 3, x minus 2. Don't forget the 4x to the 4th is still out here. So now it's completely factored, so let's find the solutions. So the solutions are x equals negative 3, because of if you set x plus 3 equal to 0, you get x equal to negative 3. This one would be x equal to positive 2. And then this one, the 4x to the 4th, is x equals 0. However, because it's to the 4th power, 0 is a multiplicity that occurs 4 times. So basically, there's 4 overlaying roots at 0. So if you looked on your calculator, I believe it said negative 3, 2, and then 0, 0, 0, 0. And it says that because there's a multiplicity of 0. It means there's 6 roots in total. 4 of them are just overlapping at 0. And I believe if you graph the calculator, you can't really tell because it only looks like 1 point. But it crosses at negative 3, and then it has like it crosses a little bit at 0, and then it goes back up with 2. So the graph looks something like this. And at 0, there's actually 4, because remember it's x to the 4th. There's 4, I guess, overlaying roots at that specific spot, which is interesting. Kind of weird, but also interesting how that works. And that's all because it's 4x to the 4th power. If it was 4x squared, that would probably tell me that it has just 2 overlaying points there. But in this case, it's got 4. All right. That pretty much covers it. I don't think there's really anything else. I'll do maybe one more factoring one, or at least I'll show you a couple. And you guys can kind of take a minute to look at it. That one's probably not a very nice one, but it works. But this one is basically the same as the last problem. These all have a GCF of 2x to the 4th, so you can divide out. 2x to the fourth on all those, get x squared minus 5x minus 6. And then factor that by product and sum. So two numbers that multiply and make -6 and add to make -5. So that would be a -6 and a +1. And because a is 1, then that means those are my factors. So I'd have x minus 6 and x plus 1 as my factors. And don't forget the 2x to the fourth. So my solutions here would be x equal to +6, x equal to -1, and of course, x equal to 0. But I'll have 4 roots here for the same exact reason I had it before. I have x to the fourth power. So those would be the 3 x-intercepts. But again, 0 counts as 4 x-intercepts all at one spot, which is very, very interesting. I think I'll end that video here because I've pretty much covered what I wanted to cover, and I don't want to make it too long. So I'll see you guys in class later.